All right, my math people, welcome back to the channel. Welcome back to calculus. So today we're going to be talking about the chain rule. So this happens when we have a composition of functions, when we have like a function inside of a function. So all this notation mean is we're going to take the derivative of the outside function, where the inside part is going to stay the same, and then we're going to multiply times the derivative of the stuff that's in the inside. So let's just go ahead and just run through a couple examples. So let's do something like x cubed plus 3x all to the fifth power. So now if you look, you got some stuff raised to the fifth power. Well, that'll be your whole outside f. So to take the derivative of something to the fifth power, well, that'll be 5. This will be our g part, so this don't change right now. To the fourth power. So that's just a power rule. And now the chain rule says we need to multiply this times the derivative of the inside. Well, the stuff that's in the inside is here right here. Well, that's a power rule, 3x squared, and a constant rule, plus 3. So I know when you're kind of doing it with somebody, it seems a little easy. Like, oh, that's just it. But it takes some getting used to, because these come in all shapes and forms. So what if we had something like sine of 4x squared? Well, now the derivative of sine is cosine. And again, the middle part don't change. Now you need to multiply times the derivative of the inside. And the derivative of 4x squared will be 8x. And usually they put the 8x in front. So if you want to, you can put the 8x in front so it can look like an answer in the back of your book. But multiplication is commutative. It shouldn't matter where we put it. All right, so let's do something a little more difficult, like sine of cosine of 3x plus 4, or something like this. Ooh, we got a sine inside of a cosine functions. I know y'all remember these from trig, and I know y'all used to hate them, but it's all good. So the derivative rules don't change. We take the derivative of the outside function. So the thing I see on the whole outside would be sine. So the derivative of sine is cosine. And again, this part don't change. Now to finish out the derivative, we need to multiply it times the derivative of the inside. Well, this is the inside. The derivative of cosine of some stuff would be negative sine. So here, let's just throw the negative out here. And the inside don't change. Well, it's another chain rule because we need to multiply this times the derivative of the inside of sine, which is just 3. So you definitely can have chain rules within chain rules. These probably going to be like the hard problems on your homework. Let's just do one more. Do something like tan of 4x divided by x to the fifth plus x. So now instead of just remembering the chain rule, you need to remember your quotient rule also. This is a function divided by a function. So our quotient rule said we need a derivative of the top, which is secant squared. This does not change. And the chain rule says we multiply times the derivative of the stuff that's in the inside, which is just 4. I'll just tag that in the front right here. Times the bottom. Minus, now we leave the top alone. And the derivative of the bottom is 5x to the fourth plus 1. all over the bottom squared. Now I know you might be, eager to or urged to simplify, but my opinion, the more simplification you do, the more you can mess up your algebra, the more points you can get took off. If I was you, I'd leave it like this for my full answer. I'm pretty sure you should get full credit.